Neutrophils are responsible for destroying invading organisms, helping prevent infection. Chemotherapy can cause suppression of the hematopoietic system, reducing neutrophil levels, which leads to increased risk for chemotherapy-induced neutropenia. Plinabulin is an investigational agent and first-in-class selective immunomodulating microtubule binding agent, or SIMBA, that binds to microtubules at a unique site on beta-tubulin. Binding of plinabulin to tubulin leads to the release of GEF-H1 from microtubules. In hematopoietic stem cells, the release of GEF-H1 drives increased neutrophil production in the bone marrow. Protection of bone marrow progenitor stem cells occurs through mitigation of the myelosuppressive insult, resulting in an increase in absolute neutrophil count in circulation. Studies have shown that activation by plinabulin plays a role in protecting progenitor hematopoietic stem cells in bone marrow during chemotherapy. Chemotherapies are known to kill cancer cells, and we also know that activation of our own immuno-oncology system is an effective way to fight cancer. Plinabulin's selective immunomodulating microtubule binding agent properties enhance maturation of dendritic cells, which stimulates T cells, leading to death of cancer cells. In dendritic cells, plinabulin binds tubulin, leading to the release of GEF-H1 from tubulin and thus the downstream activation of JNK via Rho-A-ROCK. This activation of the JNK signal transduction pathway leads to the maturation and activation of dendritic cells, driving expression of CD80, an essential cell surface receptor, allowing them to activate T cells. Inhibiting the polymerization of tubulin, thus releasing GEF-H1, also stimulates dendritic cell tumor-associated antigen presentation to CD8-positive T cells. This initiates tumor cell recognition and enhances the tumor cell response by T cells. Plinabulin's immunomodulatory action also enhances tumor infiltration. Addition of plinabulin to a radiotherapy plus anti-PD-1 immunotherapy regimen potentially increases tumor infiltration by CD8-positive T cells and dendritic cells. Plinabulin also inhibits polymerization of tubulin, activating the GEF-H1 JNK pathway in tumor cells. Plinabulin's SIMBA mechanism of action drives unique immunomodulating activities that impact neutrophil loss and can produce an anti-tumor response.